All right, here we go with section 3.5, proving parallel lines. Trying to move the mic a little bit because I know that the previous notes have been hard to read or to listen to vocally, so hopefully this one will be a little bit louder. With section 3.5, we're working on proving parallel lines. So a couple slides here I need to slide through real quick. So parallel postulate. With the parallel postulate, it says if given a line and a point not on the line, there exists exactly one line through that is parallel to the given line. So just a postulate here. And the converse of the corresponding angles postulate, again, is just the idea that if you have corresponding angles, that they are equal, then that means that we have parallel lines. These right here, again, trying to prove parallel lines, so alternate exterior angles. If alternate exterior angles are congruent, then lines are parallel. If we have consecutive interior angles and they are supplementary, which means they add up to 180, then we know that we have parallel lines. If we have alternate interior angles and they are the same, then we have parallel lines. And then the perpendicular transversal, the converse is stating again, if we have a line that's perpendicular to a line, also perpendicular to another line, then those two lines are parallel. We're not going to do proofs this year, so we're just going to go right through these slides, and then we're going to get to this question right here, which is kind of a common theme that we're going to see in this section. So it says, given angle 1 is congruent to angle 3, is it possible to prove that any of these lines are parallel? So what you have to do is you have to take a look at angle 1 and angle 3 and remember our vocabulary. So if you look at angle 1 and angle 3, they are in what I consider the lower right of our cluster of angles. And so therefore they're in the same location, which means they are corresponding. So yes, if angle 1 and angle 3 are congruent, which means yes they are because they're corresponding, then yes we can conclude that line A and line B are parallel. So next slide here says given the measure of angle 1 is 103, so angle 1 you can write in 103. Angle 4 is 100. So then we want to know, do we have parallel lines? So what we look for is what type of angles are these? Well, these are called alternate interiors, and alternate interior angles have to be congruent in order to have parallel lines, and you can see they are not congruent since one's 103, one's 100. So therefore, in our specific answer here, is they are alternate interiors, but they are not congruent. So they're not congruent, so we do not have parallel lines. So next slide, again, taking a look at here, it says given that angle 1 is congruent to angle 5, do we have any parallel lines? So again, angle 1 and angle 5 are called corresponding because they're in the same location of the clusters. So yes, the lines are parallel, but then you have to determine which lines are parallel. So you have to look and see which lines that they're talking about. And so and you're looking at the lines that form the angles. So we're going to look at line L and line N. So final answer will be option A. Again, corresponding angles are congruent, lines are parallel. Next example here, we have angle 4 is 105. We have angle 5 is 70. So what type of angles do we have here? They're called consecutive interiors. Hopefully you learned that or remember that from your vocabulary. And if you remember, consecutive interiors have to be supplementary. Does 105 plus 70 equal 180? That is a no. So therefore, our final answer or option is D. It is not possible to prove any of the parallel lines. Next slide again is using the idea that says find the measure of angles ZYN so that they are parallel. So they're saying they are telling you that we have parallel lines. So if they are parallel, then these angles have to follow through with parallel lines. Well, what we have is we have alternate exterior angles. So alternate exterior angles are equal. So we go 11x minus 25 equals the 7x plus 35. And again, I know it's hard to see this as an 11. So we would subtract over, we get 4x. So we're going to end, then we add over the 25. So 35 and 25, that gives us 60. And then from here we divide by 4, and x is 15. So we find that x is 15, but again, that's not the original question that they asked for. They wanted you to find the measure of ZYN. So where's ZYN? Here's ZYN is right here. So we're going to go 7, take out the x and put in the 15 plus 35. So when you multiply these together, we end up with 105 here plus the 35 here gives us a grand total of 140. So that is the final answer in this problem, 140. Apologize for the announcement, but got to do what I got to do here in the middle of the day. So last problem here, again, it says that they are parallel. So what we have here is we have alternate interior angles right here and right here. Alternate interior angles are equal, so we set these equal to each other. 7x minus 3 equals the 9x minus 21. We solve here, we get 2x is, let's see, 18. We divide by 18, or both divide by both sides by 2, and we get x to be 9. Final answer is option B. So again, you can see what we're doing here in this set of notes is we are using our vocabulary terms to answer what we need to find. So hopefully you learned those special angles that are formed by parallel lines cut by a transversal. Thank you, great job.